As the industry faces a swift return of passenger traffic, airports are dealing with an increased number of delays. Inexperienced new hires, lack of resources, and financial constraints all lead to a very reactive airside environment. With a growing number of unforeseen last-minute changes, airports must face the challenge of expensive delays and cancellations of flights. Many airport operations managers believe that methodologies such as Airport Collaborative Decision-Making, ACDM, are only beneficial for large hub airports and are too expensive to be adopted at their airport. They assume that only a full installation of ACDM can provide value and would never be feasible for them. With these assumptions in mind, many airports are resigned to continue with legacy, siloed methodologies, leading to expensive delays and excessive queuing at runways. And these costs aren't minor. With an average of nearly $74 per minute of delay, airport operators are under serious pressure to perform more efficiently. It's a cold morning, and the airport prepares for its initial wave of departures. Ground handlers, fueling trucks, and other staff get the aircraft ready for departure. Given the weather, most aircraft start to show a small layer of frost on the wings, so the de-icing trucks are ready at the de-icing pads. In the control tower, the controllers study the scheduled departure times to prepare the team to deal with the steady flow of aircraft to the runway and takeoff. On the ground, flights begin to approach their scheduled departure times. Handlers encounter unforeseen delays, as newly hired employees are not as quick as the experienced staff. They notify the pilots of the delays and continue to prepare the flights for departure. Meanwhile, the controllers in the tower are frustrated, as they have no visibility of when the delayed flights will actually be ready for departure. The escalating number of delays means they will have to deal with the same number of flights in a much smaller window of time, exceeding the capacity of the runway. Regardless, they go ahead and give permission for the initial flights to push back. The aircraft taxi to the de-icing pads, then to the runway holding point for departure. A queue starts to form as flights are taxiing for departure at a greater pace than the runway departure capacity. The pilots who have been in line the longest request priority for takeoff, hoping to avoid having to de-ice all over again. The controllers try to adhere to their requests, but the layout of the airport means that the planes are stuck in a single-file queue and cannot accommodate taking over other aircraft. As a result, they must go back and get de-iced again, causing additional load on both the de-icing agents and the runway demand. Flights leave the airport with an average delay of 30 minutes, causing a knock-on effect on that aircraft's scheduled segments. The inability to share data across the airport ecosystem will cost the airport thousands of dollars today. But what if ground handlers, airlines, air traffic control, and the airport all shared their data regarding flight status? If one stakeholder suffers from a delay, they could notify all the others, giving everyone time to plan and react to the deviance from the schedule. This minimizes disruption, while also significantly reducing taxi time, which in turn lowers the cost and environmental impacts of excess fuel burn. Methodologies such as ACDM have proven to enhance airside operations at airports. With Airside Optimizer, SITA is taking ACDM and breaking it down into small, value-added services to allow airports of all sizes to benefit from such clear efficiency and cost reductions. In a full SaaS model, airports can subscribe to the services they require and add more as they evolve their airport operations, so they only pay for elements they need when they need them. SITA Airside Optimizer is accessible from any device, anywhere, bringing the power of operational gains to airports of all sizes.